Okay, anyway, average atomic mass. Here we go, back to it. Average atomic mass is a weighted average of all the isotopes of an element. Okay, we use it to calculate the molar mass or the atomic mass. That's on the periodic table. Okay, that's the equation for average atomic mass. This would be used in an example problem that could look like an isotope is 30% with a weight of 49.0 and, 70% with an atomic weight of 51. What's our average, right? We would convert those percentages to a decimal before we do the calculation, and then we end up finding what's our average atomic mass. Okay? So that's just an intro. I think maybe I have one for you to do. I don't think we need to go through it. Would you agree? We don't think we need to run through that calculation. We know the only big thing I need to point out here is that when you're given it as a percentage, you have to convert it to a decimal first. So you would take 0.6917 times whatever atomic mass is given there, and then do the math. Okay? Yeah. That's the and sign. I don't know what the font it looks like that, but I don't know. Yep. Okay, I don't think we need to go through that. I feel pretty good about that. Okay, let's review molar mass. What does it mean? What's the definition of molar mass? The mass of 1 mole of any substance. That's really important. The mass of 1 mole of any substance. And when we say mole, what's that mean? 6.022. Nice. 6.022 times 10 to the 23rd of the thing, right? Avogadro's number.
Avocados.
Okay, the mass of 1 mole of a pure substance is considered its molar mass. You can calculate the molar mass of just the element, and you can calculate the molar mass of the compound itself. Okay, so the mass of just the element, the molar mass of the element, where can we find that? On the periodic table, good. And the molar mass of a compound, how do we find that?
Adding them together.
Right, we add together all of the elements that are in the
So if
compound.
there's like 3 hydrogen, like
Right.
H3CO,
Right, we would
it
take,
would be 1, 1, 1.
right,
Okay.
yep,
Plus
yep. Okay.
Chem 1 is fine.
Molar mass of an element is given. We know the difference between the units here. If you see the units AMU, that means you're talking about just one, right? 1 atomic mass unit. If you use the units grams per mole, that means we're talking about a whole mole of the substance. So if I asked you for the atomic mass, you would give the units with AMU. If I asked you for molar mass, the units would be grams per mole, but the number itself would be the same, right? The ratio, it stays the same. So, for example, carbon has a molar mass of 12, right? And then you could say it's 12 AMU because 12 atoms actually weigh 12. Or you could say, a carbon atom actually weighs 12. Or you could say 12 grams because a whole mole of carbon would weigh 12 as well. Okay. Molar mass of a compound means we need to take into consideration the molar mass of all the elements in the compound. So we're just going to do some practice with these. You think we're ready to get rid of the cover on our element periodic table? Nope. It's staying.
No.
You can use your own periodic table. All right, so how many hydrogen atoms do I have here?
2.
0, 2, 2.
Nice. All right, so hydrogen. Each hydrogen weighs 1. We have 2 of them. Each sulfur weighs 32. We have 1 of them. Each oxygen weighs 16. We have 4 of them. Right? So H2SO4 has a molar mass of 98. What's my units? Grams per mole. That means if we took out 1 mole, if we measured out 1 mole, right, or we counted out 6.02 times 10 to the 23rd molecules of H2SO4, it would weigh 98 grams, right? Or vice versa. If we weigh out 98 grams of H2SO4, we would have a mole, right? You can use it that way too. Okay.
I was doing geometry to teach art.
This one's a little bit more complex. Do that one on your own. From a couple answers from different people. What do we have? 149. 149 grams per mole. Okay, good. We talked about this already. When we ask for molar mass, our units are grams per mole. Atomic mass is AMU. Very rarely do we deal in atomic mass, right? We want to deal on kind of tangible units, which grams per mole is much more tangible than AMU. We don't deal with individual molecules. We deal with grams, substances, right? Adequate sizes of substance. Okay, so now that we know how to calculate molar mass, we can go into calculating what's called percent composition. What does just those words mean together? What does percent composition probably mean? Right, we're looking at the percent of what our compound is composed of, right? And we do percent composition by mass. So what we're going to do is find the percent composition of each individual element within that compound. And it's not just like if it's NaCl, right? We say if it's NaCl, it's not 50% sodium and 50% chlorine, right? If we were looking at atomic percent mass, it would. But we calculate percent mass,
Based off molar.
percent composition based off of molar mass, right? We calculate percent composition based on mass, not on the number of atoms. So, let's say if I wanted to calculate percent composition of this molecule right here, C2H5OH. And when we say percent composition, it means the percent of each element in there. Okay? We have to list all the elements that add up to 100%. Okay? So the first thing we do is find the molar mass. C2H5OH. Carbon is 12, so 24 plus 5 plus 16 plus 1. 46 grams per mole is our total molar mass. So if I wanted to find what percentage of that is made up of carbon, how would I go about doing that?
24 divided by 46.
Right, 24 divided by 46, because 24 is how much carbon weighs. 24 divided by 46, 52%. So 52% carbon. Generally, I'm going to actually ask you to take these to one decimal place because it makes our final number end up a little bit nicer. So this is really 52.2%. If I wanted to find hydrogen, nah, how many hydrogens are in there? 6. So we really have to do 6 divided by 46. And we get 13.0%. And then oxygen, we would just do 1 oxygen divided by my total, 16 divided by 46, and we get 34.8%. Okay? So how do we check to make sure our percent composition numbers are right? They have to add up to 100, right? So 34.8 plus 13 plus 52.2, 100 exactly, right? It's okay if we're ending up in the 99.9 range or 100.1 or whatever. You might have a little bit over under. It just depends on rounding. But that's the basis of percent composition, right? Percent composition is looking at what percentage by mass are each of these compounds made of. Okay, good. Is all this still feeling like review? Okay, good. Or at least easy enough to keep going. Okay. Oh, okay, I don't think we need to do 2. All right, now we're going to start looking at how we can convert things from the number of grams of a substance to the number of moles of a substance. Do we need to review? We talked a little bit about what a mole is, but I want to make sure we have a good grasp on what a mole is. 1 mole of any substance is 6.022 times 10 to the 23rd molecules or particles or whatever of that substance. Okay, so when we use the term mole, we need to think about it as it's a unit of measurement, right? It's a unit of measurement, except that it means a lot of one thing. It's like a dozen, right? Except it's a lot bigger number. If you say a dozen of anything, how many do you know is in that thing? 12. Right, but if I say a mole, I know there's this many of whatever I'm talking about in a mole. Just a lot bigger number. Okay, so it's still a unit of measurement, but it's just for a lot of something, right? A lot of little small things. So when we talk about converting between grams and moles, we're going to look at how we convert using those two things.
How many moles?
That would be, I don't know how you'd go about calculating that. You have to figure out what's exactly the mass of your hair, and you have to know what your hair is made of. Then you can calculate it. But you have to shave all your hair off and weigh it.
I did that.
Okay. All right. So So gram to mole conversions, we need to think about our unit conversion factor is molar mass. So the way we go from grams to moles or moles to grams is using the molar mass, okay? And that's important. Let's just try some here, okay? How many moles are in 14.2 grams of MgCl2? First, can you name that molecule? Magnesium chloride, good. Okay, I'm just going to walk us through how to do this, converting from, you think that's a 74 or a 14? I think it's a 7, actually, yeah, okay. I said it wrong the first time. So this is a T-chart conversion. This is a T-chart conversion. And so with a T-chart, what do we always start with? We always start with what we know, right, what we know. So we know we have 74.2 grams of MgCl2. I draw my T. Okay, so I want to go from grams of this to moles of the same substance, right? And so I get rid of grams and go to moles. Okay, I get rid of grams and go to moles. And what do I know about moles? What does it always get? Do you remember this one?
1.
Moles always gets the 1 because in our conversions, we always say our molar mass, let's see here, molar mass units are grams per mole. Grams per mole. Okay, and so when we're doing this conversion, we want to say how many grams of magnesium chloride are in 1 mole of my substance. That section of your T-chart is your molar mass. Right? How many grams are in 1 mole of MgCl2? You have to calculate that number. 24.3 plus 71, so what is it? No, it should be higher than that. You do 2 chlorines.
Oh.
95. Okay, so 95 grams is how much 1 mole of MgCl2 weighs. And so now I can look at my units and say, okay, I canceled grams, I'm left in moles, which is what I want. I multiply across the whole top, divide by the whole bottom. Do we expect our answer to be greater than or less than 1 mole? Less than, good. So our answer, I think, came out at 0.78 moles. Okay? You can start using some kind of common sense to predict that, right? I know that a mole of MgCl2 weighs 98, but I only started with 74. So that should make sense to us that we're going to end up with less than a mole. Yeah?
So why wouldn't we put for the 1?
Please just use Okay, what do we start this one with? 1.32 moles. So which one needs to go on the bottom? Moles goes on the bottom, gram goes on the top. And moles always gets the 1. So right here should be what? Not the number, but what do we call it that has to go there?
The mass.
The molar mass, right? Atomic mass or molar mass. And of Mg, magnesium nitrate, I don't know what the molar mass is off the top of my head.
148.
Okay, thank you.
Does that sound right? Okay.
Okay,
How would you solve the NO3?
So the 2 has to carry to both of these. So you'd have 1 magnesium, 2 nitrogens, and 6 oxygens.
Wait, do you just
Right.
add those together?
Now you don't add them, you multiply them.
No.
Oh, no, multiply across the whole top, divide by the whole bottom.
Oh, yeah, you're right.
So 1.32 times 148, and we get what?
195.35. That sounds like a rate for sounds like a radio station.
Okay, I have 1.42 moles of calcium nitrate. If I'm going moles and molecules, right, moles and atoms, do I need the molar mass at all? No. So for this example, do I really even need to figure out what this molecule is? I don't need the formula of this, right? No, I don't, right? And this should be worded differently. We don't want the number of atoms, we want the number of molecules.
Oh,
Okay, so I'm going to go 1.42 moles. And 1 mole is equal to how many molecules? 6.022 times 10 to the 23rd.
Can't you abbreviate it just like NA?
Right, so instead of writing it out all the time, you can just do this. NA, that means Avogadro's number.
Not available.
You don't have to write it out.
Not applicable.
You don't have to write it out all the time. If you want to just write NA, you can. That's why I had you store it as an N, because we usually abbreviate Avogadro's number with an N. But that's how it goes. Do this one on your own.
You don't even need to know.
We don't need to know the formula for acetic acid because we don't need the molar mass. Okay, a lot of people try to include molar mass in these types of problems, and we don't have to. Did we start with more than 1 mole or less than 1 mole?
Less than 1 mole.
Less
but
than 1 mole.
Not by a lot.
Not by a lot. Approximately 85%. Right? So 0.85 moles. Good. You guys are going through this fast. I like it. Now we're going to go through all 3. Grams to molecules, or molecules to grams. What's our middleman between those 2 things?
Moles.
Moles, right? Moles has to be the one that's in the middle. We can't convert directly from grams to molecules. There's no way for us to do that because we don't know how much 1 molecule of anything weighs. And we don't know how many atoms are in 1 gram of something, right? We know the conversion and the connection with moles. So we have to use moles as a middleman. Moles. Okay, here we go. Let's try this one. How many grams are in that many molecules of potassium hydroxide? Do we need to know the formula for potassium hydroxide? Yes, we do, because we're going to have to use molar mass. Anytime we say grams, we got to have molar mass. So our formula for potassium hydroxide is KOH. Good. I'm going to start with what I know. 6.244 times 10 to the 23rd. And you can't really abbreviate molecules that well. I usually I stop it after the C, but if you abbreviate it MOL, and that just means moles, right? So you can't, it's kind of hard to abbreviate. Okay, molecules goes on the bottom. Moles goes in the middle, right? We got to go from molecules to moles, then moles to grams. So what goes with molecules always? 6.022 times 10 to the 23rd. Moles always gets the 1. Then we convert from moles of KOH to grams of KOH. Moles still gets the 1. And what goes with grams? Molar mass. Good. So 39 plus 16 plus 1. So 56. No? 56. So the important part for us to look at is we canceled molecules, we canceled moles, we're left with grams, right? We want to make sure that our units got put in the right spot. Multiply across the top, divide by the whole bottom. What kind of number are we looking for here? Really big, really small? Or in the middle?
Right in the middle.
Average, right? We started with just over a mole, right? We started with just over a mole, agreed?
Yeah.
So we should end up with just over 56. 58.06 grams. Okay. I do think it's important for us to carry our labels through because when we start doing stoichiometry and we start dealing with 2 different compounds, it's going to be important for us to remember which one is which. So that's just something for you to be thinking about. Okay. Are we feeling comfortable with conversions all the way through?
Yeah.
I feel like you guys are moving and grooving. Okay. Good. So do you want to do another one or are you feeling okay? Okay. All right. Then you're going to have some time to do your homework. All right. I want you to type in this link right here. I just want some feedback on what you learned today and what you still have questions about.
There you go. Check out the computer.
You don't need a computer. It's fine.
It doesn't need your opinion.
Well, I'll just have you do it on my iPad or something.
All right.